Okay, alright, so here's our notes for today, lesson 1 of this week, graphing reciprocal functions. Covered this back in, oh goodness, October? Question mark? I call them baby rationals at the time. Alright, so, normal intro stuff for the week. Here's lesson 1, lesson 2, and the links to everything. So getting here into lesson 1, okay, watch the video notes. Hi. Join me for the live stream right now. They'll be re-uploaded later. The notes are down on the bottom. Print them out if you want to. Probably not going to do all the problems. This week, instead of offering both a digital and a paper activity, it's kind of a digital activity. It's through ixl.com. I think similar to Khan Academy-ish as far as like the quizzes on Khan Academy go. Okay. So open up the Google Doc for the activity. Make sure that you upload a photo of your work. That one, for this lesson, it is a bit difficult to show work on these problems. It's very much just kind of looking at it and either reading the equation or reading the graph for certain attributes. So that's understandable if that doesn't happen. Actually, I will delete that. They do have running scores. I'll be checking those scores on Sunday to transfer them over to Google Classroom probably on Monday or Tuesday of next week. Okay. So to get into the activity itself, everything open already. Good job. Step 1 will be to go to ixl.com. Step 2 will be logging into your account. Your username and password were sent to your Seguin ISD email. Reach out to me if you can't find it. This is what my email looked like when I made a demo account. Okay. Click on the skills suggested by your teacher up here in this red box. It's a bit bigger. This is a screenshot just from Algebra 2. But you'll pick on the first one that will say rational functions, asymptotes, and excluded values. And then you'll work through the given questions until you reach your desired SMART score. So it's a little bit like TSI in that it grows with you. So the more questions you get right, the fewer ultimately that you need to do, which is quite nice. But if you keep getting questions wrong, it'll slow down. It'll offer you some hints and tricks and things like that. It has like learn with an example and whatnot. Okay. And then whatever SMART score you get, that's the grade that will transfer into Google Classroom next week. Alright, so getting into the notes. Okay, there's a blank copy of the notes as well as a already filled out teacher copy. I write my domain a little bit different than she did, so we'll get into it. Okay. Oh, I don't want to do that yet. Alright, so the reciprocal parent function is just the really basic rational function, being 1 over x. And that guy is the one, let's see, 1, 1, 1 half, 1 half. Whoa. Looked something like this. Terribly inaccurate graph. Okay. Type of graph. This actually is a hyperbola. We didn't talk about that during that unit because we hadn't covered conics yet. Alright, our domain, let's see, because it has that asymptote through the y-axis, the domain is everything but 0. And the range is everything but 0. So those are the excluded values of 0 and 0. Vertical asymptotes affect our domain, or are affected by our domain, rather, or vice versa, honestly. X equals 0, and horizontal, y equals 0. If you remember, like a little acronym that you may have learned in Algebra 1 of HOIVUX, horizontal asymptotes are y equals, vertical asymptotes are x equals. Okay. Alright, closing out of that. So standard form, getting into like the different transformation statements of these things. I typically use A, B, C, D. They used H and K for these notes instead of C and D, but it's the same-ish. You know this. Yeah. So H is our horizontal. Too lazy for that. Horizontal shifts, where if it is a positive value, it is moving to the left. If it's a negative value, it's moving to the right. K is our vertical stuff. Positive is going up, negative is going down. If your A value is negative, then it is reflected across the x-axis. Sorry, I thought I heard something. Okay. If A is greater than 1, that is a vertical stretch. And otherwise, it is a vertical compression. In general, your vertical asymptotes are going to be at x equals h, and horizontals at y equals k. Headphones are weird. They're noise canceling enough to tune out most of the stuff going on in my house, but I'm hearing my dog snore. Okay. Alright. Writing, we'll do like one of these. Maybe two. We'll do the first and the last one because they're different. A reciprocal pairing function reflected across the x-axis. Translated for write 3 down. Write the equation. Tell me the asymptotes. Okay. So if it's being reflected, I just know that it's going to be negative. 4 right and 3 down. This doesn't tell us anything about any stretches or compression, so I'm going to assume the numerator is a 1 then. Okay, so this has a vertical asymptote going through x equal 4 and a horizontal asymptote going through y equal 3. Okay. Number 3, a reciprocal function has a vertical asymptote located at x equal -2 and a horizontal asymptote at y equals 5. Write the equation. Okay, so the whole x equal 2, what that's telling you is that your h value is -2. And this is telling us that our k value is really 5. So if I wanted to write that type of function, that would be 1 over x plus 2, or change out the sign, plus 5. Boom. Alright, moving on. Okay, we're so not going to do all of these. Yeah, no. Okay. Alright, 4 and 5. Graph each function, determine the domain, range, and asymptotes. And another way that IXL poses these questions talks about excluded values. So, where the asymptotes are. And specifically the x values. So, like your vertical asymptotes. Alright, so 1 over x minus 2. So, if I am graphing these lovely buggers by hand, I find it helpful to kind of talk about where the vertex is. Really, these don't have a vertex. So this one happens to have its 0, -2. And the reason I do that is so that I can kind of draw in my asymptotes. And then I use that as a guide for helping me draw it. So we arrowheads, because it does go on to infinity. Okay, so this thing has a domain x values cannot be 0, because it's defined everywhere else. So that means in turn it has its vertical asymptote at 0. This is a range where y values can't be -2, and so because its asymptote is at -2. Yay. Right. 5 is extremely similar. do some of the other ones. Okay, I'll do 6 and 8. 6 so that we have something with a negative going on. Yeah. Okay. So on 6, let's see, our vertex, if you will, would be 0, 1. It's not in any way affected by the vertical stretch by 4 in reflection. Like, it has nothing to do with it. Because multiplying doesn't change that type of thing. So, whoops. 0, 1. Okay, so it is being reflected. So instead of it existing in essentially the first quadrant and the third quadrant, is being reflected over the x-axis, so it's going to exist in the second quadrant and the fourth quadrant. Yay. Okay, doesn't really do much for the domain. The domain in this case is still can't be 0, and the range in this case can't be 1. So our vertical asymptotes, our excluded value is 0, and our horizontal asymptote is through 1. Okay. Boop. And number 8. So this one's going -4, -7. So I'll start there. So -4, 1, 2. Okay. And then it's being stretched by 2, but it isn't causing any reflections or anything. So it's going to be in quadrant 1 and quadrant 3-ish. Technically hits all the quadrants, but assuming that to be like our new origin. Yeah, we're just getting a rough sketch of these. Frankly, I don't really think there's too much of that on the IXL activity. It's more about the asymptotes and the excluded values. So this one can't be through -4 because that's where its asymptote is, and it can't go through the y value of -7 because that's where its asymptote is. Yay! Alright, so key things I want you to keep in mind here is that IXL does play around some different verbiage on these problems. So I'm going to pull it up and show those a little bit to you. Sorry, it's probably loud. Okay, PreCal rationals. Okay, so what is the equation of the vertical asymptote? So in this case, you just want to keep in mind, okay, so vertical, if you think like Hoy-Vux, that's going to be our x equals what x value is it not going through? -4. Okay, and it is wanting an equation, so it should have an equal sign. Okay. Jump up a level. This one says like what is the excluded value for y equals 1 over x minus 6. So it's really that's kind of getting at our vertical asymptotes again. So this case is 0. It's like what value can't be plugged into the equation or goes undefined. Okay. Yeah, so this would be like x equal -7. Whoa. That was wrong. Oh, horizontal. I didn't read it close enough. Well, good thing, because this is what happens when you get a question wrong. It breaks it down like this. They use B and C. You could use a poop emoji, and it would still mean the same thing. Cool? Got it. Alright, let me know if I can be of any help. I'll be available to answer some emails and be on Google Hangouts for a bit.